let's look at the probability of disjoint and overlapping events. So when you consider all the outcomes for either of two events, A and B, you form the union of A and B as shown in the first diagram. When you consider only the outcomes shared by both A and B, you form the intersection of A and B as shown in the second diagram. The union or intersection of two events is called a compound event. So if we're looking at these here, notice that they are overlapping. Okay, so these are overlapping. So to find the probability of A or B, you must consider what outcomes, if any, are in the intersection of A and B. Two events are overlapping when they have one or more outcomes in common, as shown in the first two diagrams. Two events are disjoint or mutually exclusive when they have no outcomes in common, as shown in the third diagram here. So the intersection of A and B is empty. They have nothing in common. So this is what we call disjoint. Oops. What happened? Disjoint. All right. So the probability of compound events, if A and B are any two events, then the probability of A or B is this. So it is to find the probability of A or B, so or, equals the probability of A plus the probability of B minus the probability of A and B, right? So we have to subtract out the intersection of those events. If A and B are disjoint events, then the probability of A or B is this. So it's just the probability of A or B equals the probability of A plus the probability of B. And that should make sense because looking up at this example here, we don't have to subtract out what they have in common because they don't have anything in common at all. Okay? So let's try these out. A card is randomly selected from a standard deck of playing cards, of 52 playing cards. What is the probability that it is a 10 or a face card? So is this going to be overlapping or disjoint? So a 10 or a face card. So if you remember, face cards are king, queen, and jack. So we're looking for king, queen, and jack, and then we're also looking for 10s. So first of all, let's figure out the probability of A, which is drawing a 10. So probability of A, so that's drawing a 10. So we can have a 10 heart, a 10 club, a 10 spade, or a 10 of diamonds. Okay, so it's probability of A. The probability of B, then, probability of B is a face card. So we have king, queen, jack of hearts, king, queen, jack of diamonds, king, queen, jack of clubs. It's my club. And then king, queen, jack of spades. Okay, king, queen, jack of spades. So that's probability of B. So there's no intersection here. So all we need to find is the probability of A plus a probability of B. So the probability of A, so we have 4 chances of drawing a 10 out of 52 cards. Plus the probability of B, well, we have 4 suits times 3 of these cards. So 4 times 3, that is 12 out of 52. So then you add them together, it's 16 out of 52, or 4 out of 13, which is 0.308. So let's try the second example. Finding the probability of overlapping events. A card is randomly selected from a standard deck of 52 playing cards. What's the probability that it's a face card or a spade? So we know that we have spades. So the probability of a spade, and that is our ace of spade, 2 of spade, 3, and so forth. So I'm just list them: 5, 6 of spade, 7, 8, 9, and 10 of spade. Okay, and they also have jack, queen, king of spades. Okay, so those are all our spades. Then it says the probability that it is a face card. So a face card, we're kind of looking at our example up here at the top. So we have kind of the same things. We have the probability of face card, which is king, queen, jack of heart, king, queen, jack of diamond, king, queen, jack of clubs. And then we have the king, queen, jack of spade, which is already here on this side. So that's actually jack of spade, queen of spade, and king of spade, right? So those are overlapping. So here's a probability of a face card versus the probability of a spade. So this is overlapping. So in this case, we're looking at the probability of A or B. So it's overlapping. A or B equals the probability of A plus the probability of B, and then we have to subtract out the overlapping. So the probability of A and B. Okay, probability of A and B. So probability of A, we'll say probability of the spades, there are 13 cards out of 52. Then the probability of the face cards, well, there are 12 out of 52. Then the probability of A and B, that's the intersection, it's right here. So we have to subtract out the 3 out of 52, or we're double counting it. So now we have 13 plus 12 minus 3, that is 22 out of 52. And then that reduces to 11 out of 26, or that equals 0.423. Okay? So now you try these out. Try selecting an ace or an 8, selecting a 10 or a diamond, and pause the video and try it out. Okay, so hopefully you tried this out. And so the probability of an ace, there are 4 aces in the deck out of 52, or the probability of an 8, so there's also 4 out of 52. There's no overlapping, so these are disjoint. So you just add them together. This is 8 over 52, which is 2 out of 13, or 0.154. So selecting 10 or a diamond. So a 10, there are 4 10s in the deck, and diamonds are 13, but it is overlapping. They have one card that's overlapping, the 10 of diamond. So we take the probability of 10 plus probability of the diamond minus the probability of both. So it's 4 out of 52 plus 13 out of 52 minus 1 out of 52 equals 16 out of 52, which is 0.308. So what you want to remember is that when two events A and B overlap, as an example 2, probability of A or B does not equal the probability of A plus the probability of B. Okay, so just remember you have to subtract out what's overlapping.